Hello, friends. Welcome to the science show. And one of the biggest mystery of universe today is that the understanding the neutron stars and what could be the constituency of neutron star. Are they made of plasma? We know that the temperature of the neutron star is very high. Or are they made of liquid or are they made of gas? What is the kind of material that will form the surface of the neutron star? We already know that they are very highly energetic bodies and have lot of mass. In fact, a teaspoon of material of neutron star may weigh as much as the entire Mount Everest. So we know that one teaspoon of the material of neutron star weigh as much as huge billions of kilograms, because it's very compact and the material itself is made of neutrons. But then there are a lot of videos around it, so I'm not going to in depth about the neutron star. But I think today we want to nail based the characteristic of the surface of the neutron star, and is it really solid or it's liquid or gas. And the latest studies have shown that. So the observation of a neutron star, there are variety of neutron star, and there is one particular type of neutron star called Magnetar. Magnetar is very few in numbers. I mean, apart from so many billions of neutron stars that exist in our galaxy, we have so far seen only 31 magnetars. Now, what is so specific in magnetar and why it is called magnetar? Because these neutron stars having lot of magnetic field, and the magnetic field is so strong that it can actually rip apart atoms. So that is a type of magnetic field this type of neutron star depicts. Now we don't know until now that what is the main reason why magnetar produces so much magnetism. And another thing is that if it is producing so much magnetism, that means there must be liquids moving around, metallic liquids moving around and rubbing with each other inside the body, and that could be responsible for generation of the huge magnetic field of the magnetar. So until now, this was a sort of a black box for most of the humans. But the latest study has shown that it has a solid surface. It is the surface of the neutron star has no atmosphere. So first of all, it is completely solid, and second is it has no atmosphere at all. That means there is nothing, no gas that can exist on a neutron star, and specifically on magnetar. Now this study will help us also determine why certain neutron stars exhibit the ability to generate a lot of magnetic force. And that is what the subject of discussion today. And as we know that all the stars are made of plasma. Now plasma is the fourth state of matter that we know of. And the property of plasma is it is neither liquid nor gas or nor a metal, but it has property of all three. That means it is as hard as solid, it is as flowable as liquid, and as permeable as gas. So it's a very strange state of matter, and any matter can become a plasma. So most of the stars, in fact the entire universe, is made of plasma, which is the fourth state of matter. So once the neutron star is created, is it made of plasma? Because if it is made of plasma, then we can identify that it generates magnetic field, especially in the magnetars. And what will happen, is there a duration to which it will generate? So there are a lot of unanswered questions. But to start with, let's assume that neutron star is also made of plasma, but the plasma is made of entirely neutrons, and there could be some sort of flow inside neutron star which will generate the humongous magnetic field, and that is why we call them magnetars. So magnetars generate a lot of gravitational gravity as well as the magnetic field. So we know that the neutron star, which is a type of a magnet star, generates a lot of gravity, and the magnetar has a lot of magnetism also in it, and it is so strong, it's very scary. You cannot approach a magnetar without getting ripped apart even before you reach near it. So magnetic field can actually destroy you when you try to approach a magnetar, and that is why there are only very few we have detected so far, based on their magnetic activity and magnetic energy. And now the latest study have shown that the freshly made neutron star can be magnetars, and over time they will tend to solidify, and over time the liquid which is in motion internally will stop slowly or slow down. So roughly it is estimated that whenever the neutron star is found, it actually remain in the magnetar form for about 10,000 years. After that, it runs out and the magnetic field decays. So this is what, because this was a mystery and we were trying to understand the reason behind that some neutron stars are neutron stars and some are magnetars, and why not all the neutron stars are magnetars. So this is something this latest study and this simulation can throw some light on this mystery. And the another mystery is that the neutron stars rotate quite rapidly. The neutron stars, the normal neutron stars, rotate something like 10 to 15 times every second, and that is why another name for neutron star is given is a pulsar, which is that it generates a lot of pulses. Whereas the magnetar spins slower. That means it has one spin in every 2 seconds, whereas the normal neutron star spins rapidly. So I think there is still a mystery that why magnetar spins slowly and a neutron star spins very rapidly. I think that is something which we will come to know with more studies. But this is one characteristic of the magnetar, that magnetar spins at least 20 to 30 times slower than the normal neutron star. So if they are formed newly and they are exhibiting a lot of magnetism, still it is shrouded in mystery. And the way we actually conducted this study is basically studying the polarized light. Now, polarized light is just like laser. That means you polarize the light in one particular direction, and that light is made of photons. So it's a wave associated with a particle. So when the photon is moving in one direction, when we look at the white light, as I'm trying to show in this picture, white light is unpolarized. So the oscillation of these photons can be in any direction, but you can then polarize the light and start vibrating in only one direction. Now, once you are able to polarize light and convert that into something called laser, that means it will have only one oscillation. It can actually travel to very far off distances without getting distorted. So we know already all this for about 100 years, and when we study these magnetars light which is coming, even though the light they emit are in the X-ray or the gamma ray spectrum, we can still study, and they are completely polarized. And since they are polarized, we can actually make a lot of deductions, and we can understand the by studying the light coming from these neutron stars and magnetars, and make calculations, apply our equations on the light, and then we can actually determine what could be the interior of the neutron star. And because of the polarized light which is coming out from the neutron star, we are able to get this polarized light on Earth. And when we actually study the polarized light, we know that when the polarized light passes through an atmosphere, just like we have an atmosphere on Earth, then it actually changes its parameter. So while it has traveled through space for billions of light years, but when it enters the Earth atmosphere, the interaction between the atmosphere gas molecules and gas atoms, the light will change its polarity. So we know this phenomena, and the same is true when the light is coming from a far off star system, even from sun. When the sunlight is actually coming to Earth, we actually single out the light which is polarized and also unpolarized, and we know that the sun has an atmosphere. So there is one viewer, Priya Verma, saying hi Priya Verma. If you have any question about the science show, please feel free to write in. All right, so even the sun atmosphere, which is known as corona, can change the polarity of the light. So that is what we have seen. We know that this is a phenomena which exists, and the assumption was, when we are actually studying the light coming from the neutron star, it must be if there is a little 1 centimeter thick atmosphere, or the atmosphere of the gases, then it will change the polarity of the light which is being emitted by the neutron stars. Even if neutron star has a very thin atmosphere, it has the ability to change the polarity of the light. But in the case of magnetar, we do not notice any change in any polarity from the polarized light. And when we say that, when we study this, we assume that there is no atmosphere at all. So the assumption now is that the atmosphere the gaseous, because the temperature of neutron star is very extremely high, so there must be some gaseous stuff around it, and being attracted by the gravity of the neutron star. But because of this high magnetism, the material which exists in the gas state also act like solid. So that is why the atmosphere, the molecules in the atmosphere, or the plasma which is surrounding the neutron star, which are specifically magnetars, are behaving more like solid, and that is why there is no distortion in the polarized light that we have noticed so far. And that is the reason that we are able to deduce that these magnetars are a special type of neutron stars. Probably they are the freshly born neutron stars, and they will actually have the magnetic field running for about 10 to 15,000 years, and they are completely solid because the magnetism is so high, it solidifies the gas or the plasma that surrounds the neutron star. And because of that, we know that the neutron stars may have an atmosphere, but the magnetars do not, and they are completely solid, and they exhibit certain different activities which will diminish with decay in magnetism. As the time passes, the magnetar liquid activity reduces, and it becomes a neutron star. So this is something which is as per the latest study, and I thought I will discuss this latest finding in the science show. So friends, thank you very much for joining me in this live stream, and I look forward to receiving your comments and your suggestions. Any questions you have, I'll be more than happy to answer. So see you in the next episode. Until then, bye bye.